Welcome to my YouTube channel Civil Engineering Creation. Today we will solve a simply supported beam with symmetrical trapezoidal load. This type of load usually seen on the division of two-way slab. First of all, we will calculate the support reactions, then perform an equilibrium check, and at the end we will draw a free body diagram, shear force diagram and bending moment diagram. Let's start the calculation of reaction forces. Here you can see we have a beam with trapezoidal load. We will divide this beam into different sections to calculate the area and with the help of area we will calculate the total load acting on the beam. So let's start the calculation of total load. We will calculate these three shapes and at the end we will add them to get the total load. A1 will be the triangle and the area of triangle is 1/2 base into height. Here the base is 2 meter and height is this 5 kilonewton per meter. So A1 will be 5 kilonewtons. Similarly for A3 this is also a triangle with base 2 meter and height of 5 kilonewton per meter. So A3 is also 5 kilonewtons. And this is the rectangle with base 4 meter and height of 5 kilonewtons per meter, and the area of rectangle is base into height. So the A2 will be 20 kilonewtons. Now add these three to get the total load, that is 30 kilonewtons. As you can see, if we cut the beam into two halves, then the left half will be equal to the right one if we consider the loading on the beam. So we will divide this total load by 2 to get RA and RB. RA and RB both will be 15 kilonewtons. Let's perform an equilibrium check. For that we will consider the second condition of equilibrium, that is sum of all the forces acting in vertical direction will be 0. RA and RB both are positive as they are acting in upward direction, and this total load is acting in downward direction, that is minus 30. So the sum of all these three is 0. It means our reactions are correct. Let's draw a free body diagram. Here you can see we have a beam AB of 8 meter length with trapezoidal loading of 5 kilonewtons per meter, and the support reactions RA and RB both 15 kilonewtons. Let's draw a shear force diagram. For that we will use the area method. For the drawing of shear force diagram, divide this beam into three portions. The first half is the A1 triangle, and the second half is the A2 rectangle, and the third half is also a triangle A3. So here you can see 15 kilonewton is acting in upward direction at A. So draw a line of 15 kilonewton in upward direction. Now calculate the total area for this triangle A1, which will be half base into height. So this area is 5 kilonewton. As the load is acting in downward direction and the loading is parabolic, so we will draw a parabolic curve at 15 kilonewtons in the downward direction up to the 10 kilonewtons. Let's calculate the area for this rectangle, which will be base into height, and that is 20 kilonewton. Again this is in downward direction, so draw a line up to 10 kilonewton in the minus direction. Plus 10 minus 20, which will be the minus 10, so that's why it is in downward direction. Now let's calculate the area for third portion, that is again triangle, which will be half base into height, and again this is 5 kilonewton in the downward direction. So again draw a curve up to minus 15 kilonewtons, and at the end we have a force, that is reaction RB in the upward direction of 15 kilonewtons. So minus 15 plus 15, we are again at the 0 line. So this is our shear force diagram with this positive region and this negative region, and the shear force is 0 at the center of beam. At this point the bending moment is maximum. So let's draw the bending moment diagram. For that we will use again the area method. The area of this shear force diagram will be the bending moment. So here you can see we will calculate the total area for this portion, and the other half will be replicated in the downward direction. Both are same. Up to the center 4 meter the bending moment will be maximum because the shear force is 0. Let's zoom this region to understand the calculation of area. Here you can see we have divided this region into 3 different shapes. The first one will be the M1, and this is the M2, and this is the M3. M2 is the rectangular shape and M3 is the triangular shape, and this is also looks like a triangle with parabolic height. So let's calculate the area of these 3 regions. First of all, we will calculate for M1. For this type of shape, the formula for the calculation of area is 2/3 base into height. Here base is 2 meters and height is 5, so this will be 6.667 kilonewton meter. Now calculate for this rectangle. That is very simple, base into height, which will be 10 is the height and 2 is the base, so this moment will be 20 kilonewton meter. And for this third part, this is the triangle. The area of triangle is half base into height, so the moment will be 10 kilonewton meter. Now add all these 3 to get the maximum moment for this beam, which will be 36.667 kilonewton meter. Let's draw a bending moment diagram with maximum bending moment up to 4 meter, that is 36.667 kilonewton meters. This is our problem. This is the free body diagram. This is the shear force diagram with maximum shear force of 15 kilonewton, and this is the bending moment diagram with maximum bending moment of 36.667 kilonewton meters. This is our today's lecture. Thanks for watching.